Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on circle geometry again for mathematics grade 11. And this is Theorem 5, which goes the opposite angles of a cyclic quadrilateral. That's the name of the theorem. Without further ado, let's look at the summary of the video. Step number 1, which is number 1, we're going to look at what the theorem is and understand the meanings of the words. Number 2, we're going to look at what the goal is, what are we required to prove. And step number 3, which is number 3, we're going to look at the strategy. How do we go about showing that the sum of the angles that are opposite in a quadrilateral are supplementary. Number 4, how to apply the theorem using examples from past exam papers. Let's start. The name of the theorem is simply opposite angles of a cyclic quadrilateral. Now the statement goes, the opposite angles of a cyclic quadrilateral are supplementary. Now before we go further, this is step number 1. Step number 1, know your theorem. Know your theorem. What is the meaning of the word supplementary? And what does a cyclic quadrilateral mean? Step number 1, let's analyze the word. So it says the opposite angles of a cyclic quadrilateral. Firstly, a cyclic quadrilateral is a quadrilateral, a four-sided shape, whose vertices, the corners, lie on the circumference of the circle. So all 4 vertices, the corners, must lie on the circumference of the circle, must touch the circumference of the circle. In other words, for example, this is vertex 1, vertex 2, vertex number 3, vertex number 4. So all of these vertices are on the circumference of the circle. If that is not the case, remember the circumference is the edge of the circle. If that is not the case, then it is not a cyclic quadrilateral. And I'm going to show you examples of more cyclic quadrilaterals. Now we're told that the opposite angles of a cyclic quadrilateral are supplementary. The word supplementary means to add up to 180 degrees. The other one, which is complementary, means to add up to 90 degrees. Now, what this means is that angle B plus angle Q equals to 180 degrees, or angle A plus angle P is equals to 180 degrees. These are the opposite angles, and when we say a supplementary, that means when you add them together, they end up to 180 degrees. That's what the theorem is about. Now, step number 2, it leads us to step number 2, which is the goal. Now that we know what the theorem is about, now what is the goal? What are we required to prove? We just looked at that. We're required to prove that angle Q plus angle B equals to 180 degrees, and or angle A plus angle P equals to 180 degrees. Now that we know what the proof is, the goal is, now let's find a way to now prove the theorem. So step number 3, what is the strategy? How do we go about proving that the opposite angles are supplementary? Now there are 2 tips on how to prove this theorem. Number 1, you use angles around a point, angles around a point, and you will see how that is relevant now. And number 2, we're going to use the theorem that goes angle at center is equals to twice angle at the circumference. These 2 strategies will help us immensely, because that's exactly what we need in order to be able to prove this theorem without any hitches or glitches. Now let's start. So the theorem, before we start proving the theorem, we need to make a construction. So step number 1 would be to make a construction, and the construction in this case is very easy. Construction, you just join AO and join OP to show that angle Q plus angle B is equals to 180 degrees. If you want to show that angle A plus angle P is equals to 180 degrees, you just join OQ. Let's use a different color red. You just join OQ and OB to prove the second pair equals to 180 degrees. So let's go. Let's prove that AQ equals to Q plus B equals to 180 degrees. So using the blue construction. Now let's remove this and use the blue construction. Right, let's fix that. Now here is the proof. Construction, we're joining AO and OP. OA and OP. That's what we're joining. Now that we've joined this together, notice that angle O is now divided into two angles. One on the side of the construction, looking at Q, and the other one, number 2, at the side of the other side of the construction, looking at B. Now, angle O1 will be equal to twice angle B. Angle O1 is equals to twice angle B, and the reason is simple. Angle at center equals to angle at circumference. Twice angle at circumference equals to twice angle at circumference. Same story with OT. Angle O2 is equals to twice angle to B to Q. Angle O2 equals to twice angle Q. Same reason. Angle at center equals to twice angle at circumference. Now, notice that the sum of angle O1 and angle O2 is 360 degrees because these are angles around a point. But the sum of angle O1 and angle O2, that gives us 360 degrees, and the reason is angles around a point. Angles around a point. Now, therefore, now what we do is we substitute 2b for O1, therefore 2b plus 2q is equal to 360 degrees, and now therefore factorize 2 times angle B plus angle Q equals to 360 degrees, meaning that angle B plus angle Q is equals to 180 degrees. When you divide both sides by 2. And there you go. So now, similarly, you can make a construction joining. Similarly, you can make a construction joining. You can make a construction joining OQ and OB to prove that angle A plus angle P is equals to 180 degrees. So let's just write that similarly, you can show that angle A plus angle P is equals to 180 degrees. Therefore, opposite sides of a quadrilateral, opposite angles, sorry, of a cyclic quadrilateral are supplementary. A cyclic quad are supplementary. And that's how you prove that theorem. And we're done with this theorem. It was actually very easy. It's a very easy theorem to prove. Now, let's go ahead and look at examples from past exam papers. 12.1 says, in the diagram below, O is the center of the circle, PSRT. PSRT is a cyclic quadrilateral. You're being told, prove the theorem which states that angle PTR plus angle PSR is equals to 180 degrees. We are now asked to prove the same theorem we just proved. So what is the construction? We make a construction. There is the construction. Join. Okay, no. We are proving the other ones now. Let's join. join PO and RO. So we want to prove angle T plus angle S equals to 180 degrees. So we join OP and, okay, proof, join, okay, construction, we are joining OP and OR. Join OP and OR. Okay, we'll let this be angle O1 and that is O2. Angle O1 equals to 2 times angle S. Angle O1 equals to 2 times angle S. The reason is angle at center equals to twice angle at circumference. Angle at center equals to 2 times twice angle at circumference. Same story, angle O2 equals to 2 times angle T. Angle O2 equals to twice angle T. Angle at center equals to twice angle at circumference. Twice angle at circumference. The sum of O1 and O2 is equals to 360 degrees, but angle O1 plus angle O2 equals to 360 degrees. And the reason is angles around the point. Angles around the point. Therefore, now let's substitute O1 for 2S and O2 for 2T. Therefore, 2S plus 2T equals to 360 degrees, meaning that, let's factorize now, meaning that angle S, 2 times angle S plus T is equals to 360 degrees. Now we divide both sides by 2, leaving us with 180 degrees, and there you have proven it. There, proven. Next, let's look at 12.2. AP and CP are tangents to the circle center O. That's with center O. Angle P equals to X. There is angle P. That is equals to X. We are told that AP and CT are tangents, so we know that they are equal. I just want you to have that already in, and the reason is very easy. Prove that angle AOCP, this is a cyclic quadrilateral. Okay, let me highlight this in red, or we can make it purple so you can see for yourself. Let's highlight this. Let's highlight this in purple so you can see it. There is the cyclic quadrilateral we're supposed to prove. Prove that AOCP is a cyclic quadrilateral. Now here are the 3 ways you can prove that a quadrilateral is cyclic. Cyclic quad proof. Reasons. The first reason, you can prove that opposite angles are supplementary, meaning that they add up to 180 degrees. And the second way you can prove that a quadrilateral is cyclic is that you can prove that show that the exterior angle is equal to the interior opposite angle. Number 3, you can show that angles in same segment equal. Angles in same segment equal. For this one, we do not have angles in same segment, so this one automatically falls away as a method we can use to prove. So let's eliminate this one. It's not going to work for this one. And then exterior angle equals to interior opposite angles. We don't have the size of angles here, so we're not able to undoubtedly prove that or show that. Now, the only option we have is to use opposite angles supplementary, meaning that they add up to 180 degrees. How do we then go about that? Notice that OA is the radius and AP is the tangent. So we start with that. We start with the fact that these are tangents, so meaning that this angle AOAP, is equal to 90 degrees, 12.2.1. Angle OAP is equal to 90 degrees. Reason? Tangent perpendicular to radius. Tangent perpendicular to the radius. Yes. Similarly, angle OCP is equal to 90 degrees. Same reason. Tangent perpendicular to radius. Angle OCP. Angle OCP is equals to 90 degrees. Same reason. Tangent perpendicular to radius. Tangent perpendicular to radius. And notice that these two are opposite angles of a quadrilateral. Therefore, AOCP is a cyclic quadrilateral. Therefore, OCAP, AOCP is a cyclic quadrilateral. Cyclic quad, and the reason is angle OAP, opposite angles supplementary. Opposite angles supplementary. Supplementary. Why? Because therefore angle OAP plus angle OCP is equal to 90 plus 90, which is equals to 180 degrees. That is why. Next question. Prove that 2 times angle B is equals to 180 degrees plus x. Now notice that twice the angle AOB, right? This is the angle. This angle, let's call this angle O1, and this is angle O2. Let's call this angle O1. So what we need to show here is to show that basically this angle O1 is equal to angle 180 degrees plus x. That's what we need to show ultimately. So let's start with O2 plus x. Notice that angle P plus angle AOC, which is angle O2, add up to 180 degrees. Angle P plus angle O2 equals to 180 degrees. And the reason is opposite angles of a cyclic quad. We just proven that this is a cyclic quadrilateral, so We have that opposite angles of a cyclic quadrilateral. Therefore, angle O2 will be equals to 180 minus P. Therefore, angle O2 will be equals to 180 degrees minus P. But we know that angle P is equal to X. Therefore, angle O2 will be equals to 180 degrees minus X. All fine and dandy. Now let's find the size of angle O1. But angle O1 plus angle O2 add up to 360 degrees because they are angles around a point. Angles around a point. Therefore, angle O2, therefore angle O1, which is the size that we're looking for. Therefore, angle O1 is equals to 360 degrees minus 180 minus X, which gives us what? 360 minus 180, so that will be 180 degrees minus negative X plus X. There. So angle O1 equals to 180 degrees plus X. 180 degrees plus X. But notice that this angle O1 is equals to twice angle B. And the reason is, but angle O1 equals to twice angle B. And the reason is angle at center equals to twice angle at circumference. Therefore, therefore 2 times angle B is equal to 180 degrees plus X. And that's how you prove that. Now we've come to the end of this video. Thank you so much for watching. I'll see you in the next video. Thank you. Bye-bye.